Let's see Leetcode problem 155 minimum stack. First we will understand the problem statement and then we will see the approaches. First is brute force approach and second one is optimal approach. At the starting you will not understand the problem statement, but as you see the code I am dry running, then you will understand the problem. So let's get started. Let's understand the problem minimum stack. This is a medium level stack problem. We have to design a stack that supports push, pop, top and retrieving the minimum element in the constant time. Okay, so you will not understand by seeing these examples. Okay, so here is an methods which is a minimum, stack, push and pop. Okay, and top. These are the and get minimum. These four are the main functions in the means methods in the Java. Okay, and we have to perform these methods. Okay, so you will understand the problem. I will explain the problem statement and I will explain the approaches on the paper pen. So let's go on paper pen. Let's understand the problem statement. We have to perform these operations. Okay, push, pop, get minimum, push, pop, get minimum. Okay, these operations we have to perform on stack. Okay, you have to not see the example given on the Leetcode. You will not understand by seeing that example. Okay, so I will explain. Okay, so I will explain by explaining you approach. Okay, then you will understand this problem. First we will explain the approach 1, brute force approach. Okay, so we have to perform push operation, pop operation, top operation and the get minimum operation. Okay, these are already present in the stack in Java. Okay, these are the predefined. Okay, so we have to perform the get minimum also. Okay, so I will take one example. We have to push 5, -2, 0 and -3. Okay, so first I will push in the stack 5, -2, 0 and -3. Okay, first we have to find the get minimum. So how we will find this get minimum from this stack? Okay, so simply we will create here one temp minimum temp. Okay, stack. Okay, now we will put these all in the this. Okay, so we will take here one count as something to store the minimum value. Okay, so first we will take the 3. Okay, here will be minus 3, sorry, -3 and we will put this into 3. Okay, 0. Now 0 is less than -3. No, now we will we will traverse each and every element from the stack. Okay, so it will be put here. Okay, -2 will be put here and -2 is not smaller than -3. Okay, now we will put these all elements in this. Okay, now count is -3, get minimum. Now we will get the -3. Okay, now we have to pop the element. Okay, from the original stack. Okay, so again we will put this all in this this stack. Okay, these all in this stack. First step we have put this in this. Okay, now we will put all these element in the original stack. Okay, we have to pop the element. We have popped the element -3. Okay, -3 is popped. Okay, now our stack looks like this. Okay, we have to find the top element. At the top there is 0. Okay, now again we have to find the get minimum. So again we will put these all elements in the minimum stack, means temp stack. Okay, so this this will increase the time complexity of our program. Okay, because we are traversing again and again elements from the stack. Okay, and this will not done in the constant time complexity. Okay, so we will not see the brute force approach. So simply we will see the efficient solution approach 2, which is an optimal approach. Okay, we will same we will create here one minimum stack. Okay, but at the starting what we will do, we will push the 5. Okay, push 5 we will push 5 in the normal stack also, and if the stack is empty, minimum stack is empty, so I will show the description also, push the in the actual stack. Okay, if the we have to push into in the minimum stack also if the stack is empty or top is larger than that element. Okay, so this is an empty, so we will push 5 here also. Now we will push the -2 is less than the peak element of the minimum stack, so we will push that also, -2. We will push the 0 in the actual stack. Now we will see 0 is larger than the peak element of the minimum stack, so we will not push it into minimum stack. Okay, so we will move forward. Now we will push the -3 in the actual stack. Okay, now we will compare this. -3 is less than -2, so we will push -3 in the minimum stack also, minimum 3 minimum. Okay, so finally we will perform these operations, get minimum. While getting minimum we will pop the element from the stack. Okay, minimum stack. So -3 is got. Okay, now here -3 is popped out. Okay, sorry, popped out. No, we have got the minimum element. Now we have to pop. We have popping the from actual stack. -3 is popped out. Okay, -3 is popped out. Now we will compare here. peak element of minimum stack and the popped element are equal, then we have to pop from both stacks. Okay, so minus 3 also popped. Okay, you understand that if the you can see here I have written this pop element from the actual stack and pop the element from the actual stack is equal to and equal to same to the minimum stack top, then we have to remove that pop that element from the minimum stack also. Okay, now our stack will look something like this, actual stack and this is minimum stack. We have to find the top element. Here top element is 0, so simply it will return 0. Okay, again we have to find the get minimum. So we will to getting the minimum we will look at the top of the minimum stack. Here top of the minimum stack is -2, so -2 will be here. Okay, and here -3. Okay, so simply we will perform these operations on the Leetcode code editor. Okay, so you will understand more by seeing the code. Okay, so let's go on Leetcode screen. Let's understand the code. First we have to create one stack. Then we have to create one minimum stack. Okay, so stack integer stack. Okay, then we will take the minimum stack public here. Okay, so in this we have created one new stack now, so stack equal to new stack. Okay, and minimum stack. Okay, so minimum stack equal to new stack, and then we will implement the push operation. Okay, so we will push the in the normal stack. Okay, stack dot push first. Okay, and value, and we will check if uh, if the minimum stack is empty or value of the value means this value is less than the minimum stack at the peak. Okay, so if minimum stack is empty or value is less than equal to minimum stack dot peak element. Okay, if this satisfies, then we have to push it into the minimum stack also. Okay, so minimum stack dot push value. Now we will implement the pop operation. Okay, so we will create here one variable integer popped value. Okay, int popped value equal to stack dot pop. Okay, we will pop the value from the normal stack. Okay, and if the popped element is equal to the minimum stack peak element, then we have to pop from there also. Okay, so if popped value is equal to minimum stack dot peak element, then we have to pop from there also. Okay, so minimum stack dot pop. Now we will implement the top operation. Okay, so simply we will return the peak element of the stack. Okay, so here we return stack dot peak. Okay, now we will implement the get minimum operation. Okay, so get to get the minimum we have to see the peak element of the minimum stack. Okay, so here we will return minimum stack peak element. Okay, so let's compile the code. Okay, here I think something went wrong. Okay, it should be capital minimum. Okay, and where in the everywhere we have to make, so I will keep it m small and I will change in the main. Okay, here I will change it to the small minimum. Sorry. Okay, so let's compile the code once again. Here is empty. Sorry, here rounded bracket are missing. Let's compile the code once again. Okay, our code successfully compiled and our all test cases are running successfully. Let's submit the code. Sorry. Okay, our code is successfully submitted. So this was our day 25 of 100 days of code DSA challenge. And if you want the code of Java and C++, both codes are uploaded on my GitHub account, and that GitHub account link is given in the description. You can find the code in the description. Okay, so thank you guys for watching my video. If you liked my video, then like, share and subscribe my channel.